All right, so let's learn how to deploy a classical balancer with TCP listeners. Okay, so classical balancer you can either deploy HTTP, HTTPS, or TCP or and SSL, or you can just mix them. You can either deploy HTTP, HTTPS plus a TCP listener. Okay, all right. So let's assume you want to SSH to your backend servers. You don't want to connect to them directly. You want to SSH through the load balancer. Okay, and at the same time provide access to them over port 80. So we go with TCP because SSH is a TCP protocol. Okay, it's not a HTTP protocol, it's a TCP protocol. So we need to have a TCP listeners to enable us to SSH to our backend servers through the load balancer. Okay, and maybe if you want to access your backend servers, you can deploy a TCP listener as well. Okay, or we just had another HTTP or HTTPS listeners here. Okay, all right, so no problem. Let me just duplicate this and intentionally let me just make this HTTPS 443. So this is gonna be a mixed protocol configuration. You're going to configure both TCP listener and HTTPS listener. Okay, but our main concern here is TCP. We did HTTPS HTTP listener on the previous video. Okay, all right, so let's do that. So I have the two servers running. Okay, and they are running Apache on HTTP port 80. And as you always know, TCP port 22 is SSH, and this SSH is always open by default. Okay, all right. But any HTTP protocol that's running at the backend is only the guy here, HTTP port 80. Okay, so let's learn how to create a classical balancer with the TCP protocol and also blend it with the HTTPS protocol. Okay, then create a Route53 record so that we can access our backend over our custom domain name. All right, so let's go here and go to load balancers. I have the two servers running here. Okay, they're both running Apache web server. Okay, all right. Okay, so go to load balancing under EC2, then create load balancer. Classical balancer is the one below. So expand that one and create. Now we are going to create TCP listener, but I'm going to blend it with one HTTPS listener so for better understanding. Okay, right. Choose the correct VPC. Choose at least two subnets for availability. Then choose the correct security group. Then the listeners. When you reach the listeners, now we go back to our architectural diagram. So we have three listeners. One HTTPS 443. Another one is TCP port 80. TCP port 80 is just equivalent to HTTP. Okay. TCP port 22 is just equivalent to SSH. Okay. All right. Let me do that. So first of all, let me start with the TCP listeners. I'm gonna start with the TCP listener on port 22 for SSH. So this one should correspond to what the backend is listening on. I mean, my interest is to connect over SSH. So that tells me that my backend as well should be SSH, not port 80. That will bring port mismatch. Okay, because we're connecting for port 22, but the server is giving you on port 80. That's mismatch. If you're connecting port 22, that's SSH. So backend should give you SSH connection. Now let's go to TCP port 80. That's okay. My backend actually is listening on port 80. Then to blend with HTTPS, maybe for better understanding, 443, the backend is still listening on port 80. That's okay. All right. Then we choose a certificate for the HTTPS listen. Okay. All right. Then LJX will run for HTTP protocol. Okay. All right. So in that regard, and register targets, add all of them, and confirm. So we have registered that one. Okay, everything's okay. And just create a load balance. Oops. Display the listener protocol, and they must be at the same layer. Okay, yeah. These are TCP. So TCP port 80, TCP, okay? TCP port 80 is still equivalent to HTTP, okay? All right. So ensure it's TCP to TCP, TCP to TCP. All right. Okay. And then I think now everything's okay. I just create. Perfect. So we're going to wait until all the instances created are in service. Then we begin to test. Okay. So we're going to test for TCP port 22, TCP port 80, as well as HTTPS port 443. So the classic load balancer operates both at layer 7 and layer 4. So it can do some network capability, network layer capability, as well as application layer capability. Okay. In contrary to network load balancer that only deal with network layer capability, application load balancer deals with application layer capability. Okay. Right. Perfect. So let's go to instances. So we will wait until they become in service. Yeah, so this tells that it's close. It's very close. So we just try. Yeah, perfect. Now it's in service. And our classic load balancer is ready. Now, communication from here, we've achieved this one, okay? Now we can use the Amazon provided DNS name for the load balancer to test. Okay, so let's copy this one. Then go to listeners. Check. First, let's try with the HTTPS. So I'm just going to type HTTPS, paste that one, and hit enter. Perfect. So you can see it's connecting over HTTPS, but we're getting this warning because our load balancer, we've selected a certificate from this domain, but by default, Amazon provides certificate from this domain. So the mismatch provides the insecure thing. But if I can try to reach, I'm able to reach my backend, okay? And as well, let's try on TCP port 80. TCP port 80 is just equivalent to HTTP, okay? All right, so HTTP on port 80. Perfect, no problem. You can see it's all going through. Perfect. Now, what's remaining is just to test this listener. We've tested TCP port 80, which is equivalent to HTTP, okay? This one, we've tested. So what's remaining is just to test this one, okay? TCP port 22, which is SSH. So how do we SSH? Let's go to my terminal, which is, I'm gonna use the Tabby terminal, okay? Then, remember while you are creating lists, this one does not support Linux commands. When you are creating your instances, you chose a key pair. And my key pair actually is here under downloads. So under my terminal, which is Tabby terminal, I'll go to downloads directory and try to SSH. So SSH, okay. Then we choose the key pair. The key pair actually is there, which is key.pem. I've chosen it. Then Ubuntu. Ubuntu is our username. Okay, for the default username of our Ubuntu instances are always Ubuntu. Okay, then I paste this one, the load balancer DNS name. Pretty much simple. I paste it there and hit enter. You can see it's asking me to connect, which I'll say yes. And let's see, perfect. I'm connected to one of the servers which at the back end. So let's see that server. Behind this classic load balancer are two servers. Yep. So let's see which one is having the private IP address of 162 that ends with 162. Yeah, it's this one. You can see I've been connected to that server. Okay. And I can run some commands, sudo apt update. Yep. Perfect. That's how to connect it. But our main objective was to use Route53 provided domain name to connect. Okay. So let's go to Route53 and create the record so that we can do everything using the custom domain name. So it's here. Then let's create a record. Let's name CLB3, I think. It's a hair record type. Alias to be classic load balancer, which is here. Then we choose region is US East 1, where your load balancer is deployed, not Virginia. Okay. US East 1. Then you choose your load balancer, which is CLB3 as well, and you create. So as we wait that to finish, I'll just copy this record, clb3.gurutech.com, until we wait this one to be in sync. So just keep checking. Perfect. So you can see the record has been created. Now we can try to test. First of all, we tested with HTTPS. So let me just paste it there, which it should give us the default Apache page. And if you check the certificate here, it's from the wildcard one, okay, that we created. Perfect. And then another thing that we want to do, let's now test it over HTTP port 80 for TCP 80 listener. TCP 80 listener is just HTTP, okay? And let's see. Okay, let's just test it from an incognito window. It should be HTTP port 80. Okay, then hit enter. Yep, it should be insecure because it's HTTP port 80. You can see it's secure because it's HTTP port 80. Then finally, let's do SSH. Okay, so what I'm gonna do, just SSH. Then what I'm gonna delete is just the previous domain name and replace that with the one that you created on Route53. Oh, it should not be a URL, but a domain name. Perfect. Now let's see. Perfect. So it's asking us to connect. Just say yes and connect. Perfect. You can now see we've been connected to the other server. Previously, when we were doing the first SSH connection, we went to 10.02.162. Now we're going to 10.02.58. That's the workload balancer to connect to equally distribute traffic to the registered servers. Okay, perfect. Guys, thank you so much for watching this video. So I believe you've achieved the objective here. And in the next video, let's learn how to deploy SSL listeners on classic load balancer. Thank you and see you again in the next video. Bye bye.